Welcome. This is a video on an intro to statistics, chapter 1. I'm going to cover the first section here called 1.1, and then I'll make a video for 1.2 and 1.3 as well. So hopefully you've got something to jot a few things down and that my ideas are presented clearly. Here we go. I guess to summarize what we are going through this particular chapter is finding data or collecting data that is appropriate. How do we set that up? How do we do that? How do we ensure that we're using proper methods? And so they break this into 3 sections. First of all, thinking on the front side of it, and then this data that I pick up, how do we classify it? And finally, what are the methods for gathering the data? All right, first of all, just our thinking on the front side of that, the process. The first part is the preparation part, and that is including looking at the context of the data. What is the source of my data? And again, what is that sampling technique or the sampling method? Chapter 2 will be mostly analyzing, and we'll be concluding all along in different stages. And part of that is embedded in every chapter, so to speak. Okay? First of all, some data, some vocabulary. Make sure that you have these written down either on a card or in your notes. I think of all the things, this is probably the most important. I think the general ideas and gists you're going to understand and intuitively know that, but the words sometimes may slip by. The data that we collect is, in essence, what we call observations that have been collected. All right, written down in some sort of format, right? Statistics. This is a general word that is used to describe the science of planning, studies, and experiments. Obtaining the data from those studies, experience, then going through a process of organizing, summarizing, presenting, interpreting, blah, 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 and finally, drawing some sort of conclusions. Because we don't want to have all that fun without like ending up somewhere new. All right, so those are kind of two very big general words, and now for 3 more peculiar words that we will be using in class. Population. A population refers to the complete collection under consideration. And this can be the population of a classroom, this can be the population of the world, right? Or it could be the population of your neighborhood, or some sort of like biological items in a petri dish, right? And in terms of how we like look at that population, we have basically 2 options to gather our data or observations from that. We can, number 1, do a census, collect data from every member of the population, and that is tedious and expensive. Or we can do a sample, a sub-collection of the members. And this is the more popular one. It's the one that we tend to use just because it's less expensive. Okay? Here's an example. CO detectors, carbon monoxide detectors, which are in every house or should be in every house. And according to the book, they quoted a statistic where, I don't know what year it was referenced, but there are 38 million CO detectors in the US. They sampled 30 of them. Now they didn't say how, and that seems like a really small number, I agree, whatever study this was, like why did you pick just 30? 12 of these, though, that were sampled Maybe they came back as returned items or something, I don't know. They failed to provide an alarm. All right? So our population here is obviously 38 million CO2 detectors, and our sample is 30 CO2 detectors. All right? So again, notice we didn't do a census. That would be very impractical to try to like go out and gather data from all 38 million. All right, so let's look at kind of this preparation portion of our role as statisticians. Here we have a data table, and it's horizontal in nature, and it is about manatees. And we've got pleasure boats. That's what the P boat stands for. Our first column, and our second column is manatee fatalities, which means deaths, sadly. All right? So we can look at our first year here of 99,000 fatalities, or sorry, pleasure boats, and there were 92 fatalities. The second year after that, there was 99,000 boats and 73. And we can continue to look at this data, and we're kind of encouraged, one would say almost, to kind of like arrive at some sort of pattern. Is there a relationship? For example, the context of this would imply that as the boats increase, then the deaths increase. And that may or may not be true. We would have to kind of bear that out, look at the data. Well, before we jump to conclusions, we'd better check our sources. Like, where did we get these numbers from? Well, if you read the example in the book, it says this is from the Florida Department of Motor Vehicles and the Florida Marine Research Institute. And I'm guessing the motor vehicle one gave us the pleasure boats and the Marine Institute gave us the fatalities. All right? We don't know what sampling method was used to collect the data. In general, I suppose you could make a blanket statement and say official government records need to be reliable. And so, yeah, we can lean on these and know that somebody wasn't just making up those numbers. Okay? So we're fairly confident that their methodology of choosing, of coming up with these numbers was good. All right. Here is an example, though, of a bad way to collect data, which is used frequently because it's very cheap. We do it at school. We do it in newspapers. You'll see it on shows online, and it's called voluntary response sample. And the problem here is that the respondent, right, whoever fills out the questionnaire, they decide to be included or not. All right, and because this is a voluntary response, that means you're only going to get responses from certain people. Maybe people who are passionate about the subject, and we'll see that in an example here. Number 2, ABC had a show called Nightline, and a number of years ago there was a discussion on there about the UN headquarters, all right, United Nations headquarters. Should that stay in the US? It's actually in New York. Very lovely, big, huge building. I visited it. It's quite nice. But they asked viewers to like call in or text in, like, should that building stay in the US? And 67% of their viewers, 186,000, that responded to them, 67% of that said no. You should take that building and move it elsewhere. Or if nothing else, just move the headquarters somewhere else. We'll keep the building, so to speak. Now, in this case, our source is a TV network. Is that a good source to be using? Well, TV networks work on the principle of eyeballs watching them, and so they want controversy, right? So they're if only 2% of the people said no, they're not going to run this program. So I'm not sure that they're the best people to be gathering this type of data. Sampling. Again, this looks like a voluntary sampling from what we can see. There was no method of doing any random type of sorting of people. So this is a really bad statistic. It doesn't give us much information. Instead, they cite an independent survey. Now, the book doesn't tell us what independent survey this was. Just because you put the word independent in front doesn't mean that it's a good survey. They do tell us that the respondents were randomly selected. That's good. Okay. And here we have another data item of 38% of the 500 said no. So here we have probably, this is a better source. Again, we've got a few questions here. What is this independent survey source? Who actually ran the survey? Did they have a dog in the fight, as they say, or not? And then sampling, because they say randomly, that's probably a better way than doing a voluntary. Okay? All right. Problem number 1, I think, is similar to that one too. All right. Next stage, we analyze data, right? And I'm not going to go into. I just want to come back to here again. We look at the data in terms of the context, the source, and the sampling, and then we analyze. And this is all about chapter 2 and actually chapter 3. All right. So not a lot to see here. I'm just going to say that we're going to be using statistical. We're going to be building graphs and using methods. And kids, you really need to have some sort of device. I'm going to say a graphing calculator is going to be very useful to you. I've got several, and I'll have some in the room, but with COVID and all, I can't really necessarily pass them out. Find something to do that. Normal scientific calculators do have some statistical processes in them, but not nearly as much as what we need. Fortunately, your Chromebook does have some of them, and we'll be using what we call a spreadsheet. Now, that's what the SS stands for. And we can do a significant amount of work there. Now, you can also get apps downloaded on your phones, whatever they are, whether Android or iPhone. And that certainly is usable in the class, in my class here. In a normal classroom, you wouldn't be able to use your cell phone because obviously those communication techniques especially on tests and whatnot, would be verboten, as they say. But what we want to make sure, though, is that whatever techniques we use, number one, that they appeal to our common sense, right? We've got to understand these methodologies and these graphs. If they don't, we shouldn't be using them. And finally, the methods that we use need to be sound, which means that they've got to be like approved. We can't like come up with our own techniques. All right. So that's the analyze part. Finally, when we conclude our data, we look at data and we say, is this significant, right? Was there something worthy in this data? We could go back and look at the manatees one, and I haven't done any work on this particular data set, but maybe there is no significant relationship here, right? So first of all, we want to look at, is there a statistical significance? And that means that the study, when you get the results, that they're unlikely to occur by chance. And let me give you an example here. 98 females born in 100 births is highly unlikely. Yeah? That, this is not going to happen on an average 100 births. All right? So this is hugely statistically significant. Whereas 52 female births, sorry, I should write here, unlikely, therefore statistically significant. Whereas this one, 52, well, 52 is really close to 50, and the statistics bear out that we have about a 50% chance, or actually it's 49% chance, 48.8 if you want to get real technical, and so this is not significant. All right? Practical significance. Sometimes the difference between our two results, between our results that we get, it's too small, or the treatment is not practical, meaning you've got to jump through way too many hoops to get that result, and it's just like either too expensive, not worth it, therefore most people won't bother with that. All right. Here's an example. Statistical versus practical significance. We have a company, and this actually happened in 1987, which called ProCare Industries, and they had a product that they sold called Gender Choice. Now the FDA said there is no evidence for your product, and they proceeded to ban it. So that's why the FDA exists, is they have to kind of like rubber stamp everything to make sure that it works. But they ran this with 10,000 couples, and using their product, they had 5,200 baby girls. Well, this is significant. They're actually, the fact that we're doing such a large number, right? 10,000, and you got 200 over, even though that looks like it's really close, this is highly unlikely for that to occur. Okay? But this is not, in other words, the chance of this happening randomly is highly unlikely. All right? So something was occurring, but it is not practical. The difference between 52 and 50 is so small that the fact that you would buy this product and spend money to gain that 2% is, or 3% actually, if you look at 48.8, is like minimal. Okay? So again, it's significant. It is more, right? But it isn't that much more. Finally, we close up 1.1 by looking at pitfalls in our analysis. So what things can go wrong when we analyze those that data? And number one, we have a misleading conclusion. We need to be clear to the audience when we make our conclusions, right? All statements need to be justified. We can't just say something like, oh, there's less calories, therefore it's healthier, right? We've got to be, we'll talk more and more about these two statements, correlation versus association, right? What causes what? Do the boats actually kill the manatees, or is it some other disease that is causing them to die? So we've got to be careful. Collecting reported data. No self-reporting, right? That's the whole voluntary thing, right? People will lie about their weight, they'll lie about their age, about how fast they can run when they were children growing up, that kind of thing. So we want to make sure that we collect our data. Loaded questions. Sometimes, well, I'm trying to think of the word that I wanted here. I want to say intelligent. It's not intelligent. When you word a question purposely is the word I'm trying to get at, and it'll jump back to me in a moment here. But anyways, a purposely worded to get a response. For example, let's say you asked on a phone survey, should the president have a line item veto to eliminate waste? Well, when we add a phrase like eliminate waste, we're actually like encouraging people to say, yeah, of course. Who wants waste? Well, I mean, does the line item veto necessarily eliminate waste, or does it just like further emphasize the biases of our current president? Order of the question. Yeah, there's another pitfall. The order that we put it in. So the order can affect the can affect a person's I want to say prejudice. Can affect a person's thoughts. I don't know what I was thinking there. I need to put more letters down for my clues here. For example, if you have questions like which is worse for pollution, traffic or industry, or is it industry versus traffic? Like, which one is it? Well, most people will go with the first choice. If you place it this way, people will go with the traffic. If you ask it in this way, people will go with industry. So we've got to be careful with the order of the question. Finally, non-responses. Again, some people don't respond to the question, and we need to know why. Some people hang up, and we do that a lot in our house because we suspect somebody is what they call sugging. And sugging refers to selling, yes, and polling at the same time. So like they say, oh, look, we're having a little survey on this. And it's not a survey. They're just trying to get you to buy something. All right? So some people don't respond, and we've got to be careful of that. Finally, sorry about that, percentages. There will be like alarm systems that say things like, oh, look at that. You can reduce theft by 400%. Well, what the heck? You can't reduce theft by 400%. If you reduced it by 100%, there would be no more theft. So you can't go over that. And people then misuse percentages. Hopefully, you're good with percentages and you know how to go from 32% to something over 100, right? And you can reduce those ratios and all that good thing. You can even turn it into a decimal because you're so good. All right, on math. This is typically a good strategy of setting up a ratio. X% of n is x over 100 times n, right? There are some problems involved in your homework that do that simple math. So there is this world of math. Hopefully you've been down this path of going between ratios, percents, and decimals. Be fluent in those abilities. Excuse me. Here we have a Newport Chronicle. Yeah, it ran a survey by asking readers to call in responses to the questions. Do you support the development of atomic weapons that could kill millions of innocent people? It was reported 20 readers responded that, and 80% said no, while 13% said yes. It's always kind of funny to think about those 13 people that said yeah. Anyways, what are the flaws in this survey? Well, hopefully you can see. Yeah. Asking readers to call in, right? That's a voluntary. We have a loaded question. Innocent, right? Millions. That is not as problematic. What I haven't really talked about is 20 readers. This is a really small number for a survey. And if Newport Chronicle wants to like have a statistic that's valid, having more than 20 is important. Well, your homework is listed online. Hopefully you can see that. And I wrote it out here. Good luck with those problems. And the next lesson is 1-2.